Hey everybody! So I found myself wanting to create something quite funny. So to create kind of an ecosystem inside Max using JavaScript in Max. So we will create something in which there are some creatures that we will define inside the code, and these creatures will have some behaviors, and they will have some goals. They will have some abilities that they can use, and so on. So a bit kind of in the nature of code style, because this is kind of an assignment that gets proposed inside a book from Daniel Schiffman. And yeah, I want to do something like this because I think it's kind of funny and interesting. So without further ado, let's start. First of all, let's create anyway a JIT world, because we will use Max kind of as a rendering engine. So we will use surely JIT world. Let's call it ecosys. And let's give it the full scale anti-aliasing attribute, and then maybe the size of the window, and then floating so the window doesn't disappear, and then maybe erase color. Let's erase a color. Let's erase white color. So let's have a white background, and let's activate the world with the toggle. Okay, so there it is. And then let's create our JavaScript file. So let's create a JS object, and let's call it ecosystem.js. Let's save this file in the same... let's actually first save the patch. So I will save it in my desktop. Ecosystem maxpath. And then let's actually save the JS file with the same name, ecosystem.js, on my desktop. Alright, and now let's see what do we need. So to draw our creatures, we will use probably, let's say that we want to draw triangles and circles and stuff like this. So we will probably going to use the GTL sketch object. Oh, but actually, let's not use the editor from Max. I will use Atom as an editor, so I will set auto watch 1. So this means that the code will be updated even when we save the file in Atom. Okay. So we were saying to draw these creatures, we will need probably the GTL sketch object. So I will create a variable, call my sketch, and this will be a new jitter object, and this will be the object GTL sketch. And then we have to give it the name of the world, which is ecosys. Yeah, also, this is also a string. Okay. For the moment, let's keep it like this. And then we will need something like a vector class to work with the position of the creatures and to make some vector math. This will be totally useful for our purpose, which doesn't come already with JavaScript in Max, so we will have to create it ourselves. So let's actually create it. So function vector. This will get an x, an y, and a zeta arguments. This will be the arguments of our class, and then we will have a this.x equal to x. So this will be assigned when we create an object from the vector class. This.zeta equals zeta. Alright, and then what we need is, for example, to create a function to add a vector to a scalar value. So let's create a function. So this.add equal function, and this will be our scalar value. So let's write an s. So this function will add the components of our vectors to a scalar value. So this will write this.x plus equal s, and then this.y plus equal s, and then again this.z plus equal s. Okay. Alright. And then what we need is probably a multiplication. So this.mult this will multiply our vector for a scalar. So let's write this dot x multiplied equal s, this dot epsilon multiply equal s, this dot z multiply equal s. Okay, then let's do maybe a subtraction. So this dot sub equal function s, then this dot s minus equal s. No, sorry, this is wrong. This dot x minus equal s, this dot epsilon minus equal s, this dot z minus equal s. Alright, then what do we need? Probably division also. So this dot div equal function s. So this will divide our vector for the scalar. So this dot x divided equal s, this dot epsilon divided equal s, this dot z divided equal s. Alright, and let's try now, let's see if these functions work. So let's create a new object from the class vector. So var new back equal new vector. Let's actually call it my vec equal new vector, for example 0.3, 0.4, 0.7, and then let's say my vec dot add 4, for example, and then let's print my vec dot x, for example, and let's see, we get 4.30. Okay, so yeah, this is the expected result. This is the expected result. So okay, our functions are working, our class is working. Let's maybe create also a function to print the values of our vector without having to print them one at a time. We can create a function for which the vector just prints all the values at once. So for example, this dot print, and then this will be like post this dot x, this dot epsilon, this dot z. So if we now say my vec dot print, see what we get. There's an error. So what is the error here? Oh yes, this dot print. This we were to write equal function. Stupid error. Equal function without arguments. And yes, let's actually, you can also write like vector components and then something like that. Okay. So, alright, now we have a function also that prints the components of our vector. The problem with the function that we wrote, I mean, it's not a problem, but they have they are lacking a bit of functionalities, because when we use those functions, they will affect the vector that calls them. So if I say myvec.add, my vector will be modified, but there could be the case in which I need that my function, so for example, I add myvec to 4, and I want to return a new vector with a new component. So I don't want that myvec gets modified, but I want to actually that this function kind of returns a new vector without modifying the original one that calls the function. So we have to kind of create some more functions. So let's create those. So let's write this add new equal function s, and then we can write, for example, this dot x. Now let's write something like that. Var x equal this dot x plus s. Then var epsilon equal this dot epsilon plus s. Var z equal this dot z plus s. And then we have to return a new vector. So we can create a new object of the class vector inside the class, inside a function of the same class. And then we can return a new vector called we can then return a new vector with the components added to the scalar. So let's actually try this function, and let's create a new vector here for my vec2, and then let's say my vec2 equal my vec dot add new 3.0. This function let's actually delete, and I would say my vec2 print. Oh, we forgot to put a new line after the printing function, so let's actually add another post here, so they will go now in a new line. So okay, so vector components, this is actually, yeah, now it's printing my vec2, which is the result of my vec plus 3.0. Let's actually also print my vec to check if nothing changed inside my vec. Oh, okay, so yeah, everything looks good. Everything looks good. So, alright, so we have to kind of add this function for all the functions that we created. We had to kind of add a version that will take care of returning a new vector without modifying the existing ones. So let's actually do this. So let's write this dot mult new for function s, and then let's say var x equal this dot x multiplied by s, and var y equal this dot y multiplied by s, and var z equal this dot z multiplied by s. Okay, and then let's do it with a subtraction. So this dot sub new equal function s, so x. You can actually just, oh, I forgot to add the return statement here, sorry. So return new vector x, y, z. Let's actually copy this and put it in the sub new. So instead of multiplied, we just write a minus. Alright, and then let's actually copy it again. Let's copy the whole function actually. And then let's write here, and let's write div new, and instead of a minus, let's actually put a division. Okay, so we now have also the function that gives us the new vector, the return the new vector without modifying the original one. Now we should actually take into account the case in which we want to add a vector to another. So for example, we want to say my vec dot add my vec2, for example, and we have to take into account the case in which our s here will not be an s, but actually could be also a vector. So let's actually do like this. So let's write if s dot instance of vector. So this means if s is actually a vector and not just a scalar, then we will say this dot x plus equal s dot x, because in this case s will have like an x, an y, and a zeta components. So this dot y plus equal s dot y, this dot z plus equal s dot z. So and then we have to say else sum it like if it's actually a scalar. So if it's a scalar, then sum the single components to the scalar. And okay, so let's try actually. So my vec, so this we can actually remove, and let's actually assign some components to my vec2. So for example 0.1, 0.1, 0.1, and then let's say, oh, is there a, oops, equal, yeah, forgot an equal. So myBack2, yeah, will be like this, and then if we add to myBack2, yeah, this will actually, it's actually working. So this we have to do for all the functions that we created. So also for add new, for example. So if s is an instance of a vector, can actually just copy all this stuff, else do like this. So this we have to say var x equal to this x plus sx, then var y equal to this y plus sy, var z equal to this z plus sz. So we are creating the same check to see if it's the component to which we are adding is actually a vector, and we are adding it to all the other functions that we created. So let's do it also here. So if s is instance of vector, then we have to say this x multiplied equal to s dot x, s dot y, s dot z. Else just do it in the normal way, as if it is a scalar. Okay, so if it's instance of vector, let's actually do like this. Let's bring this up on the right. So let's copy that, and let's say else. And let's modify this. So s.x, s.y, s.z, and that's correct. And then let's finish. So if this is an instance of vector, else, let's copy this. So this will be s.x, s.y, s.z. Our vector will always have a maximum of 3 components, because we actually don't need to work with vectors that have more values than more than 4 values. So let's finish. Let's copy this. Let's bring these all on the right, and let's say else, bam. So s.x, s.y, s.z. Okay, we still have a couple of functions, and then we're done. So else suck. So s.x, s.y, s.z, and let's do it for div new. Let's copy, else, bam, bam. So s.x, s.y, s.z. Alright, we are done. Okay, so okay, now we have a vector class that we can start to use for something. Now let's create our creature class. Let's create our creature class. So let's actually delete all this stuff that we created here. Let's actually put kind of a divisor in our code, something like this. Let's actually put the same one also at the beginning of the vector class. Alright. So this is a comment, as you can see. And let's go down here and create our creature class. So yeah, for the moment, let's just call it creature. So this will be kind of our basic creature. Let's say that we want to have more different type of creatures, and yeah, probably we should do something like inherit the functions of our creature class into some different creatures classes. So we will create kind of a master creature class from which we create some others as creature classes that will inherit all the functions from creature class, because the creatures all have the same abilities, like to move around, to hunt, to hide, these kind of things. So this is common to all creatures. So now let's create kind of this master creature class. Okay, so I think the creature class will get as an input a vector that contains the initial position of the creature, right? Or should actually every creature start with its own position chosen randomly in itself? Yeah, I think so. So let's actually not give any argument to this class. And so every creature surely will have a property called position. So we'll have a position in this world. Oh, and by the way, I think we will start with a two-dimensional world. So our creature will only move on the XY axis. But anyway, we created a vector that can deal also with a third component when we will need it maybe later. So the position will be a new vector, and let's start by saying that every creature is starting in the center of our world. Okay, and then let's say that this creature have a different sides, all from one to the other. So let's write a property called this.size, and let's write a random number. So let's use math random number between this function will return as a random number between 0 and 1. So this will use as a radius for the circle function of GGL sketch. So let's actually multiply it for 0.1. And then let's create actually a method for this class, which will be the method to display actually the creature. So this.display, this will be a function. And then we will use GL sketch to display the creature. So let's write my sketch dot move to. So first we have to move the sketch to the position of the current creature. So this position. Oh, actually, this position is a vector, and move to actually accepts an array as input. So we should actually create a new function in our vector class to return the vector as an array. So let's write this, and then let's write as array, and then this will be a function. And this function will return a new array with this.x, this.y, and this.z. So now when we say this position dot as array, the sketch object should be happy. And then let's say my sketch.circle, so it will draw a circle at this position with this dot size. Let's actually set a minimum size to that, so let's sum it to 0.02 for example, and actually let's put a maximum of 0.08. Okay, and let's actually also give a color to this creature. So this dot color equal, let's create, this will be an array. So let's say that this is a red creature. So these colors are in the order red, green, blue, and alpha. And then first, before we draw the creature, let's say my sketch dot color equal this dot color. And alright, we should be good.